Question number 1, we need to find the rate of change of area of a circle with respect to its radius. And two subdivisions are given. First of all, area of circle is pi r square. When we differentiate both sides with respect to radius as given in the question, when we differentiate this area, this will be dA by dr. Pi is constant, we'll take that out. And when we differentiate r square with respect to r, apply the power rule. So we get pi into 2r into r differentiation with respect to r will be 1. So we get dA by dr as 2 pi r. So this is the required general form. Now, in place of r, substitute the first subdivision, that is 3 centimeter. So we get dA by dr as 2 pi into, in place of r it is 3, so we get 6 pi. And units will be centimeter square by centimeter. Second subdivision they have given r as 4 centimeter. We get dA by dr as 2 pi into, in place of r as 4, so 4 2s are 8 pi centimeter square per centimeter. Question number 2. Volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? Let us take the length of the edge of the cube be x centimeter, volume be v. So we will take v as, we know the formula of cube is a cube, here it is x, so x cube. And rate of change of volume, since they have given 8 centimeter cube per second, we are going to differentiate with respect to time. Differentiating both with respect to time, we get dv by dt, and applying the power rule, 3x square into x with respect to t, so we get dx by dt. And in question they have given the volume of cube is increasing at the rate of 8 centimeter cube. So dv by dt is 8. As well as they have given the edge as 12 centimeter. So 3 into 12 square dx by dt. So finding dx by dt by taking 12 square into 3 to the left side. So it will be division. 12 square is, after cancelling the corresponding terms, 4 2s are 8, 4 3s are 12. Again this is 6 times. So dx by dt value is 1 by 54. With this, the question, how fast is the surface area increasing? Now, we'll denote surface area as capital S. We know the formula, that is 6a square. Here it is x. So it is 6x square. Differentiating with respect to t again. So ds by dt equal to, when we apply the power rule, so 2 6 are 12 x into dx by dt. Substituting the values, for x it is given as 12 and dx by dt we have found it as 1 by 54. Substitute that here, then cancel the terms. 6 9s are 54, 6 2s are 12, 3 4s are 12, 3 3s are 9. So we get 8 by 3. And the units for surface area it is centimeter square, and for time it is s. So 8 by 3 centimeter square per second. Question number 3. The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeter. They have given radius as 10 centimeter and radius of a circle is increasing uniformly at the rate of 3 centimeter per second. So with differentiating with respect to t, that is 3 centimeter per second. We need to find the rate of area of the, we need to find the rate at which the area of the circle is increasing. Okay, again, like the first question, write the area, it is pi r square. Now we need to differentiate with respect to time. So dA by dt, pi is constant. When we differentiate this, applying the power rule, we get 2r into r differentiation with respect to t will be dr by dt. Substitute the values. So pi into 2 into r value they have given us 10, dr by dt is given as 3. When we multiply, 2 3s are 6 into 10, 60 pi, and for area it is centimeter square and time it is second. So centimeter square per second. Question number 4. An edge of the variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume of the cube increasing when the edge is 10 centimeter long? First of all, let's take the cube edge as x. So it is given as 10 centimeter and the edge is increasing at the rate of 3 centimeter per second. So it is differentiating with respect to time again. So it is given as 3 centimeter per second. We need to find the rate of change of the volume of the cube. So let us denote volume as V. So V is equal to x cube, differentiating both sides with respect to t. So dV by dt is equal to, applying the power rule, we get 3x square into x differentiation with respect to t will be dx by dt. Substitute the powers. So it is 10 square into dx by dt value is 3. 3 3s are 9 into 100. 900. Volume is centimeter cube. Time is second. Centimeter cube per second. Question number 5. A stone is dropped into a quiet lake and waves moves in a circle at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So they have given r as 8 centimeter. The change in the radius, that is dr by dt, is equal to 5 centimeter per second. So we need to find how fast the enclosed area increasing. So the area of circle is pi r square. With respect to t, we are going to differentiate on both sides. So we get dA by dt equal to pi constant, applying the power rule for r square. So 2r into dr by dt. Substitute the known values. We get 2r is 8. dr by dt is given as 5. So 5 2s are 10, 8s are 80 pi. Units will be area at a centimeter square, time at a seconds. So centimeter per second. Question number 6. The radius of circle is increasing at the rate of 0.7 centimeter per second. So it is dr by dt value they have given 0.7 centimeter per second. What is the rate of increase of its circumference? So circumference let us denote as dc. Formula will be 2 pi r. We are differentiating both sides with respect to t. So dc by dt, 2 pi is constant, and differentiating r with respect to t, we get dr by dt. So substituting the value for dr by dt, it is 0.7. So it will be 1.4 pi, and the units will be circumference, it is centimeter, time it is seconds. So centimeter per seconds. Or if you want to further simplify, substituting pi as 22 by 7, we get 7 ones are 7, this is 0.2, 2 2s are 4, we have a decimal, so 4.4 centimeter per second. Either you can write 1.4 pi centimeters per second or 4.4 centimeter per second. Question number 7. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute. Here they have given decreasing, so we need to take it as minus. Since they have given directly as x, since it is per minute, we'll take it as dx by dt minus 5 centimeter per minute. And the width y is increasing at the rate of 4 centimeter per minute. Since it is increasing, we'll have a positive sign. So 4 centimeter per minute. And when x is equal to 8 and y is equal to 6 centimeter, so they have given x and y as 8 and 6 centimeter. Find the rate of change of the perimeter, first subdivision. So perimeter, we know it is 2 into x plus y, or you can take it as 2x plus 2y. Anyway you can take, and with respect to t we are going to differentiate. So dp by dt, here it is 2 into dx by dt plus 2 into dy by dt. Now substituting the values, 2 into minus 5 plus 2 into 4, minus 10 plus 8, it will be minus 2. Units, perimeter it is centimeter, time here they have mentioned as minute, so we will use the minutes. Second subdivision, area of the rectangle. So area of the rectangle we denote it as capital A. We know it is length into breadth. Here length and breadth are x and y. So it is x into y. Now differentiating both sides with respect to t. Here both are variables. So we apply uv dash, uv the whole dash. That rule. So dA by dt equal to x into, when we differentiate y with respect to t, we get dy by dt plus y into, when we differentiate x, we get dx by dt. Substitute the values. X they have given us 8, dy by dt it is 4, plus y given as 6 dx by dt, it is minus 5. So 8 4s are 32 and 6 5s are 30, minus we have. So 2 units will be area and time, it is centimeters square per minute. Question number 8. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeters of gas per second. Find the rate at which the radius of the balloon increases when the radius is 15 centimeter. So radius is given as 15 centimeter, and which always remains spherical on inflation is being inflated by pumping 900 cubic centimeters. So that is dV by dt value is 900. Since they have given remain spherical, we are going to take the volume of sphere. So volume of sphere is 4 by 3 pi r cube. And now we are going to differentiate with respect to time on both sides. So this will be dV by dt equal to 4 by 3 pi is constant, so that remains as it is. And applying the power rule for r cube, it is 3r square. And for differentiating r, we get er by dt. They have asked find the rate at which the radius of the balloon increases. We need to find the radius. So we'll take these all values to the left side. dV by dt is given as 900. 4 by 3 will be 3 by 4. And pi value it will be 1 by pi. Into 3 it will be 1 by 3. Into r square it will be 1 by r square. We have 15 into 1 by 15 equal to dr by dt. So cancelling, we get 300, this is 5 times, 100, this is again 5 times, 4 ones are 4, it is 25 times, 5 5s are 25, and 3 and 3 gets cancelled, so we get dr by dt as 1 by pi, r is centimeter, time is here it is given as seconds, so 1 by pi centimeter per second. Question number 9. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when the radius is 10 centimeter. So r is equal to 10 centimeter. They have given the balloon always remains spherical as a variable radius. So we are going to differentiate both sides with respect to r. Since it is spherical, we are going to use the sphere formula 4 by 3 pi r cube. Differentiating both sides with respect to r. So we get dV by dr equal to 4 by 3 pi as constant. So we don't differentiate that. And r cube, it is 3r square. So 3 3 gets cancelled. R they have given us 10. So it is 4 pi into 10 square. So 10 square 100 into 4. 400 pi. Volume is centimeter cube and radius is centimeter. So centimeter cube per centimeter. Question number 10. A ladder 5 centimeter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 centimeter away from the wall? So let us try to figure it out. A, B and C. Let this be the ladder length that is given as 5 centimeter. This be the base. Let us take it as X and the height of the wall as Y. How fast is the height on the wall decreasing? So final answer will get a negative as it is decreasing when the foot of the ladder is 4 centimeter away from the wall. So this is given as 4 centimeter. So X is equal to 4 centimeter and ladder length AC is equal to 5 centimeter and the bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. So we get dx by dt as 2 centimeter per second. We need to find y as well as dy by dt. Since it is a right angle triangle, we are going to use the Pythagoras theorem, that is AB square plus BC square will be equal to AC square. Since we need to find this y, we are going to take, so y square is equal to AC square minus x square, hypotenuse square minus the adjacent side. So here AC is 5, so 25, AC square it is 25 minus x square it is 16, it is 9. When we take the square root, it is 3 centimeter. To find dy by dt, we are going to differentiate this using the Pythagoras theorem. This is 5 square 25. Both sides with respect to t we are going to differentiate. So 2x dx by dt plus 2y dy by dt equal to, since it is constant, we get 0. Since 2 is common on both the terms, we are going to take it out. X is 4, dx by dt is 2 in a bracket. and y we found it as 3 dy by dt we need to find. So let it be asked as equal to 0. Taking this into 2 to the right side as by, so 0 by any number is 0, 4 2s are 8, taking 8 to the right side it will be minus, so 3 into dy by dt is equal to minus 8, into 3 it will be divided by, so dy by dt is equal to minus 8 by 3, units this is centimeter time is second. So minus 8 by 3 centimeter per second. Since it is decreasing, we get it as negative. Question number 11. A particle moves along the curve 6y is equal to x cube plus 2. Find the points in the curve at which the y coordinate is changing 8 times as fast as the x coordinate. So here it is given the y coordinate is changing 8 times as fast as the x coordinate. So dy by dt equal to 8 into dx by dt. Let's take this as the first equation. It is given in the question. Okay. Now we are going to differentiate this with respect to time. The curve equation. 6 into y differentiation with respect to t, it is dy by dt, and applying the power rule and differentiating x, we get dx by dt, plus constant is 0. Now substituting the known values, 6 into, using the first equation, 8 into dx by dt in place of dy by dt, and 3x square into dx by dt. Both sides, as we have as product, we can cancel this dx by dt, and 3 1s are 3, 3 2s are 6. So we get 2 8s are 16. When we take the square root, we get x is equal to plus or minus 4. Okay. So we need to find y. We need to find by substituting on this equation. So when x is plus 4, y will be 6y equal to 4 cube plus 2. 4 cube is 64, 66. So y is equal to 66 by 6, we get 11. So 4 comma 11. Or when x is equal to minus 4, we get 6y is equal to minus 64 plus 2, that is minus 62. So y will be equal to minus 62 by 6. On simplifying, we'll get this is 3 times, this is 31 times. So we get y is equal to minus 31 by 3. So the coordinates will be minus 4 comma minus 31 by 3. Question number 12. The radius of an air bubble is increasing at the rate of 1 by 2 centimeter per second. So we take dr by dt as 1 centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? So these two are given in the question. And since it is in bubble, we will take that as the sphere form. So volume will be 4 by 3 pi r cube. We are going to differentiate both sides with respect to time. So dv by dt is equal to 4 by 3 pi as constant. Differentiating r cube, we get 3r square into dr by dt. Cancelling this 3 and substituting the values. So we get 4 pi into r is 1. So 1 square is 1. dr by dt is also 1. So we get 4 pi. Units will be centimeter cube per second. I'm so sorry. dr by dt is given as 1 by 2. So when we substitute this, we get 1 by 2. 2 and 4 gets cancelled. It is 2 pi centimeter cube per second. Question number 13. A balloon which always remains spherical has a variable diameter 3 by 2 into 2x plus 1. Find the rate of change of its volume with respect to x. Diameter is given as 3 by 2 into 2x plus 1. To find the radius, we'll divide by 2. Yeah? So 3 by 2 by 2, it will be 3 by 4 into 2x plus 1. We need to find the volume with respect to x. So volume is 4 by 3 pi r cube. In place of r, it is 3 by 4 2x plus 1 the whole cube. Okay. Now we are going to differentiate with respect to x on both sides. Before that, we will try to simplify. Since it is 3 by 4 cube, I am writing as 3 by 4. Then squaring this 3 by 4, it is 9 by 16 pi into 2x plus 1 the whole cube. So 4 and 4, 3 and 3 gets cancelled. Now differentiating with respect to x on both sides. So dv by dx equal to 9 by 16 pi is constant, and applying the power rule, we get 3 into 2x plus 1 the whole square into differentiation of 2x is 2. Cancelling the terms, 2 and 8. So we get 27 by 8 pi into 2x plus 1 the whole square. Question number 14. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. So dV by dt. Since sand is pouring, that capacity, we'll take that as volume. Since it is pouring, we take it as a change. So 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that height of the cone is always 1/6 of the radius. Okay, this is also the given condition. Either we can write h as 1 by 6r or r as 6h. Either way you can substitute. How fast is the height of the sand cone increasing? When the height is 4 centimeters. So height is given and we need to find dh by dt. So what we are going to take? Since it is forming as cone, we take it as volume of cone, that is 1 by 3 pi r square h. Since height is given and we need to find dh by dt, we will replace r in terms of h. So V is equal to 1 by 3 pi, in place of r it is 6h, the whole square into h. So we get pi by 3, 6 square 36, h square into h cube. So cancelling this, we get 12 pi h cube. Now, differentiating both sides with respect to t. So we get dv by dt, 12 pi constant, h cube is 3h square into dh by dt. Now substituting the values, dv by dt they have given as 12 equal to 12 pi into 3, h is given as 4 centimeters, square is 16 into dh by dt. 12 and 12 gets cancelled. Taking this 3 into 16 to the left side, so it is 48. So 1 by 48 pi equal to dh by dt. The units will be dh by dt is equal to 1 by 48 pi. H is centimeter, time is seconds. So centimeter per seconds. Question number 15. The total cost Cx in rupees associated with the production of x units of an item is given by. They have given cost of x, that is in place of x variable. So 0.007 x cube minus 0.003 x square plus 15x plus 4,000. Find the marginal cost when 17 units are produced. So marginal cost will be the derivative of this cost, total cost. So dc by dx. We need to differentiate. So 3, it will be coming as a product. So it will be 0.021 x square minus 0.006 x plus 15 into 1. This will be 0. As x is equal to 17 units they have given, we are going to substitute. So dc by dx is equal to 0.021 into 17 square minus 0.006 into 17 plus 15. Simplifying this, we get 6.069 minus 0.102 plus 15. Adding and subtracting accordingly, we get 20.967. So the marginal cost is rupees 20.967 when 17 units are produced. Question number 16. Total revenue in rupees received from the sale of x units of a product is given by r of x as 13x square plus 26x plus 15. Find the marginal revenue when x is equal to 7. Now, the marginal revenue will be the derivative of this total revenue, that is dr by dx. On differentiating, we get as 26x plus 26 into 1 and this will be 0. Substituting x as 7 as given in the question, dr by dx value will be 26. I am taking as common. So x it is 7 plus 1. 7 plus 1 8. 26 into 8 it is 208. So the total the marginal revenue is rupees 208 when 7 units are produced. Question number 17. The rate of change of the area of the circle with respect to its radius r at r is equal to 6 centimeter. We know area of circle is pi r square and with respect to radius they have given. So dA by dr is 2 pi r. When r is equal to 6, we get 2 pi into 6, that is 12 pi. So the correct option is option B, 12 pi units. 18th question. R of x is given as 3x square plus 36x plus 5. Find the marginal revenue when x is equal to 15. For finding the marginal revenue, we will differentiate with respect to x. So dr by dx. So it is 2 3s are 6x plus 36. And when x is equal to 15, we get 6 into 15 plus 36. That is 90 plus 36. We get it as 126 rupees. So the correct option is option D, 126.